Okay, so I've come across a nice duration basics document issued or published by the California Debt and Investment Advisory Commission, and they have some definitions in terms of what bond pricing involves, discounting coupons with the relevant discount rate or yield to maturity, and discounting the face. And then they have an implementation of the Macaulay duration, which here is given as the present value of cash flows multiplied by the respective time period divided by the market value of the bond. So a particular example here where the face of the bond is 1,000 and the cash flow or coupon is 100 per annum. We have these figures on discount rate of 7%. We get a bond price of 1,078.73 and then a duration of 2.7458. Okay, so we can verify this example. Okay, it's we have a face of 1,000, coupon rate 10%, risk-free rate 7, time period 3 years, coupon is paid once a year, and using this function PVVM, okay, coupon structure, present value coupon, present value annuity structure, we can estimate the value of the bond, and likewise the duration obtained is equivalent. We can use the this formula here, our VBA code, which is basically we take the face of the bond discounted, we take the face multiplied by its time period and discount that. Then we take the coupons and discount the coupons, and then we take the duration and we discount the coupons again. So effectively the same as here, but each instance we're multiplying by its respective time period. Okay, so the I divided by M, each time period, year, or time period divided by 2. So this is the multiplying the coupon, the discounted coupon by its respective time period. When I divide the duration by its price, I get the duration of the bond. So, or when I take the cash flows, discounted cash flows multiplied by their time period, when I divide that sum put through the loop by the price of the bond, I get the duration of the bond. Okay, so it's a nice little function. It seems to work well, and I get a correspondence here. I can do that manually. Cash flows each period 100, at the end 1,100, so face and coupon. Discount factor is 1 plus the discount rate to the power of the time period, and that's the same for each. Then I take the product of the discount factor by the coupon, and likewise I get the discounted cash flows. I sum those, I get the bond price, which is the same as here. If I take the product of the respective time period times the discounted cash flow, I have this column here. So when I take the product of discounted cash flow by its respective time period, it gives me the figures in this column. I sum those, and then I take the ratio of these divided by the bond price, and I get the duration. So it's the same, and the same. Now, there is another way we could do this, and I'm going to set it up just briefly and run through. So what I'm going to use is basically these two formula here, and we can add in. So let's just take this again, copy and paste, and I'll take these two as well and copy and just paste underneath, and I'll remove this. I'll just take these and pull across, so I get rid of the duration estimate here using VBA, but I still have it here. And I'm going to follow the logic of this formula, which basically says, now it takes into account higher frequency coupon payments, so semi-annual, quarterly, but we're going to just assume M here is equal to 1 for our purposes, and I'm going to work out duration by following this construction. So we know that the change in the bond price divided by the original bond price as a result of a change in the interest rate, take Y here to denote the yield to maturity, or R, and B to be the change in bond price, and B to be equivalent to the original bond price. So we could imagine if the interest rate went up by a tiny amount, let's put 0.0001 here, and let's consider the interest rate changing, so we'll say equal to, and the interest rate goes up by the small amount. Okay, and could we estimate the duration by saying, okay, it's equal to, so this is slightly different to this type of approach, but it's equal to the change in the bond price divided by the original bond price multiplied by 1 plus the interest rate divided by the change in the interest rate. So let's try this. So we're saying the change in the bond price. Okay, so the bond price, change in the bond price as a result of an increase in interest rates. So we get a change in the bond price, and we divide by the original bond price. And then we multiply by 1 plus Y, 1 plus R, so 1 plus the original interest rate. If I divide by M here, I'm just dividing by 1, so no real effect. And then I divide by the change in the interest rate, and the change in the interest rate is this one here. Okay, and we'll look at that, and that's 2.745, and that will be minus D, so I probably should put minus here in front to get D, and it's 2745, not too far away from this one, 27457. Okay, and if I just add a few zeros, okay, 27457, and let's take this along a little bit, 76. So we're pretty much, if we go back 1, 76, you can see we're getting the same number here and here. It's just a question of rounding. Okay, 274576. And again, we can do that rounding. So take this one, go back 1, and take this one, go back 1, and we're getting the same. So basically, we can also use this type of construction where we can say, work out the bond price again, re-estimate the value of the bond, but for a tiny increase in interest rates, where dy, delta y is the change in R, which is this, it's tiny. And then, so I'll just put that beside, so this is our dy if you like. And then we estimate the change in the bond price, divided by the original bond price times 1 plus the interest rate the original interest rate or discount rate or yield to maturity divided by 1. In this case, the periodicity of the coupon is one time a year, divided by the change in the interest rate, which we had given us this tiny adjustment. Okay, and we get a correspondence, which is quite handy for introducing an alternative approach to estimating duration. Okay, now here I've done something similar. I've looked at a previous example that I addressed before, and I looked at a 5-year bond and coupon rate and yield at both 10%, so the value of the bond is 1,000, is its face, as we might expect. Then I looked at the change in the interest rate, and I worked out, of course, the bond here has M equal to 2, so semi-annual coupon, which means if we were to work this out manually and worked out in the same type of way, working out taking the product of the discounted cash flows and the respective time periods and summing those, and then taking the ratio of those two, we would get the duration. Or we could use the VBA function I developed, and we get a duration of 4.05391, etc. Not too bad. And then likewise here, 4.0539, and a little bit different. Okay, and again we could tweak this to get maybe more accurate results. Okay, but we're getting correspondence between the three. So this function, this implementation seems to work quite well. Let's see if we could set this out in C++. And I have some code that I've set out in a Word document. I might just copy that. And let's copy. And we'll take the California example. So let's copy those numbers. And I'm going to put into Visual Studio. Okay, so a Visual Studio coming up. Take a second, pause. Okay, so new project. Let's hit this and pause. And so I'll write in duration approximation and say OK. And I'm picking Win32 and Win console application. OK. And pause. Let's say next. And empty project. And I'll pause. And I've got to add a source file. So add new item. And it's C++. So we'll just add. And then I'll paste the code that I had copied from the Word document. And I think that looks okay, so I'll just run the debugger and pause. And when we look at that, we can see clearly this bond is not duration. This is for estimating the present value of the bond. So I go back and copy the code for C++ for duration. Okay, so I open that up. And so let's just copy that. Copy. And what this code does, it go back into the Visual Studio. I'll just paste. And maybe we can have a little look here at the actual code. Okay, so it's the bond. The function is PVB duration and the usual face, coupon rate, interest rate or yield, number of coupon payments per annum, and the number of time periods. I'm going to estimate two bond prices, so BV1 and a BV2, and we won't have enough time, so we'll pick this up in the next video clip.